Problem solving in chemistry. Many problems in chemistry require math, so we're going to look at the dimensional analysis approach to solving numeric word problems. In numeric word problems, first you want to analyze what's known and what's unknown. Then we're going to calculate, which for our part means converting between units most of the time. And then thirdly, you want to evaluate and make sure the answer makes sense. So let's look at some examples. This first example, we're taking a walk. Distance to be walked is 8 blocks. So I'm going to label some knowns and unknowns here. We want to walk 8 blocks. We're looking for the number of minutes, and we can walk 1 mile in 20 minutes. 1 mile is equal to 20 minutes. That's a conversion factor for us. And then finally, 10 blocks equals 1 mile. Notice I'm writing units. We need to incorporate units into all these problems. So that's what we know. Whenever I'm starting a problem, I really don't want to start with an equality. I would rather start with just a number. So I'm going to start with 8 blocks. I'm going to do this. 8 blocks, I'm going to put it over the quantity 1 to show it's in the numerator. I want to get to minutes. That's what I'm looking for. The way to cancel blocks is a conversion factor. I know there are 10 blocks in 1 mile. In order to cancel blocks, the unit has to go in the denominator in the next step. And there are 10 blocks is equal to 1 mile. So I'm going to multiply by that conversion factor. That's going to get rid of blocks. And now I'm left with miles. But I want to go ahead and get to minutes. And I know that in 1 mile there's 20 minutes. Again, canceling units, miles would go in the bottom. And 1 mile is equal to 20 minutes. So those conversion factors I use right here and right here, it changes the number but not the actual quantity. So miles will cancel out. I'm going to be left with minutes, and then I just have to solve it. So I take 8, I divide by 10, multiply by 20. So the number of minutes is 16. That's my unit up here in the numerator. That's what I'm left with. So 16 minutes. Evaluate it. Make sure the answer makes sense. Let's do the same thing in this problem. Knowns. Janzo can run a mile in 0.14 hours. So that's known. That's an equality. 1 mile is set equal to 0.14 hours. He plans on running 2.3 miles. That's a known. 2.3 miles. And then how many seconds? That's the unknown. Will it take him and his cow to run 2.3 miles? All right, so let's start off. Again, we don't want to start with an equality, so we would start with 2.3 miles. Set it over 1 to show it's in the numerator. We want to cancel miles. Here's my conversion factor. 1 mile is equal to 0.14 hours. That'll cancel mile. I want to go to seconds. I need to cancel hours. I didn't give you the conversion, but in 1 hour, I can go back to minutes. 1 hour, there would be 60 minutes. That would cancel hours. And then for minutes, I can go to seconds. 1 minute, 60 seconds. And see how all the units canceled out as I went through, and I'm left with units of seconds. So we just multiply straight across. 2.3 times 0.14 times 60 times 60. We get 1,159 seconds. And for right now, it does not matter how you round that number off. So this is okay, 1,159 seconds. Okay, next example. A lot of knowns here, a lot of numbers in this problem. Known, 12 eggs in a carton. 20 cartons to a box. 4 boxes in a crate. And then crates are stacked 5 wide, 6 deep, 5 high. How many eggs are on the truck? So this is my unknown. I also know the number of crates. 5 times 6 times 5 gives me the number of crates, which is 150. Okay, so that's my knowns. Again, I try not to start with an equality, so I would start with the crates, which I have 150 of those. And then I'm going to look at my conversion factors to get rid of crates. In one crate, I'm told that there are 4 boxes. That will cancel crates. Now I'm in boxes. 1 box, 20 cartons. That'll cancel boxes. And then 1 carton, 12 eggs. That'll cancel cartons. So see how my units canceled out as I went from left to right? Mathematically, I just have to multiply 150 times 4 times 20 times 12 to give me the number of eggs on this truck. And again, it's always a good idea to go back and evaluate, make sure that answer makes sense in realm of all the numbers that were given. 144,000 eggs on a truck. Let's look at one more conversion problem, numeric problem. Again, you're given lots of numbers here. I don't want to start with an equality if I can help it. You'll notice that we're looking for miles. That's my unknown. How many miles could Mr. Probst travel for $10? Let's start there. That's not an equality. That's just a number. Put it over 1. $10. Okay, we need to cancel dollars. Here's a conversion. $1.23 per liter. So we're going to cancel dollars, put the $1.23 down here, put 1 liter on top. That'll get rid of that conversion. So dollars is canceled. We have liters. We can go from, here's a conversion, liters to quarts. So 1 liter, 1.1 quart. Liters cancels out, so that one's gone. Now we're in quarts. Now there's a couple conversions that have quarts. 4 quarts in a gallon, 60 kilometers per quart. Now I'm trying to get to miles, so the 4 quart to gallon is not going to help me. That'll give me to gallons, but it won't help me get to miles. So I'm going to use 60 kilometers per quart. 1 quart on bottom, 60 kilometers up here. Quarts is going to cancel out. That conversion factor is written a little differently, but it's still an equality. 60 kilometers equals 1 quart. Now I've got kilometers. My last conversion that I haven't used, 1.61 kilometers. It goes down here, so my units will cancel in 1 mile. So my units have canceled, top and bottom. I'm left with units of miles. Then it's just solving it mathematically. So 10 divided by 1.23 times 1.1 times 60, and then divide by 1.61. So the number of miles that Mr. Probst could travel for $10. And again, the rounding issue, don't worry about how we round at this point. 333 miles for $10. 333 miles. Those are numeric problems. There are also conceptual problems. For example, you want to place an ice cube inside a bottle, but the ice cube is too large. How could you get the ice cube inside the bottle? Conceptual problems don't always have one correct answer. If I want to get the ice cube inside the bottle, I could melt it. I could crush the ice to make it fit inside the bottle. I could break the top of the bottle off if I wanted to. So conceptual problems don't always have one correct answer. Mostly, though, we're going to be concerned with numeric problems, like the previous 4 examples that I went through.